Okay, we're going to cover number 16 on your checklist, which is called direct variation number 2. All right, so what we want to do today is we want to identify direct variation from ordered pairs, and by ordered pairs such as this, all right, and use those ordered pairs to write equations that models the direct variation, okay? So two things that you should have remembered from the first lesson on direct variation. Number one, in the direct variation, the relationship between the variables must be proportional. Okay, so there has to be a constant ratio between x and y. Like for example, x, y. We have x is 1 and y is 2. X is 2 and y is 4, x is 3 and y is 6, x is 4 and y is 8. Then we have that constant ratio there, that proportional relationship, that for every 1 of x, there's 2 of y, okay? So the way that we check for a proportional relationship we take the ratio y over x, okay? If we look at y over x here for this table, well, for the first one, it's be 2 over 1, be 2. For the second line, 4 over 2, which is 2. For the third line, 6 over 3, which is 2. And for the fourth one, 8 over 4, which is 2. Okay? Because this this ratio is consistent throughout, meaning it's always 2, that is a direct variation. Okay? And that is our k value. All right? Remember the formula, which is your second line. If they do vary directly, then the equation is in the form y equals kx. Okay, that's your equation for direct variation. And this ratio y over x, that's our k value. Okay, that's our constant of proportionality, which means the equation for this example I made up would be y equals 2x, because 2 is the value of k. All right, let's take a look at an example. Okay, so we're given these sets of ordered pairs, these tables, and we need to determine if we have a direct variation or not a direct variation. And if it is a direct variation, we have to come up with the equation. Okay, so we want to look at the ratio of y to x for these. Okay, so I'm going to make another column within the table. All right, y over x here would be 1 over 2, or 1/2. All right, y over x here would be 2 over 4, which is 1/2 when we simplify. It looks like it's a, okay. And then lastly, we have 12 over 8, which is 3/2 when we simplify. So since the constant of proportionality is not consistent, okay, we have 1/2 for the first line, 1/2 for the middle line, and 3/2 for the last line. This is not a direct variation, okay? Y does not vary directly as x here, so there's no equation to write. Okay, let's take a look at the second one. Again, we're going to make a chart, y over x, and we're going to add to the chart. Okay, y over x here would be 5 over 4. The second one, 10 over 8. Which is 5/4. Okay, when we simplify. And then we have 15 over 12 for the bottom one. And when we simplify that, it is 5/4. Okay. So since we have that constant ratio throughout the table, 5/4, 5/4, 5/4, it is a direct variation. Okay. and y equals kx is the form of our equation. We know this is our k value, so your answer to the equation is y equals 5/4 x. Okay, so it is direct variation, and the equation is y equals 5/4x. Okay, number 3. Again, we'll add in our table y over x. The first one, that's 4/5, nothing to simplify. For the second one, it's 12/15. Okay, these are each divisible by 3, which makes 4/5. And then we got 20/25. All right, these are each divisible by 5, which makes 4/5. So we do have that constant ratio of y to x, so it is a direct variation, and our equation is going to be y equals 4/5 x. Okay, sorry about the handwriting. Okay, pause the video, try number 4, and then check back. All right, so for this one, y over x, okay, we have 5/4 here. All right, the middle one's a little trickier. We get 6.25. Oh, if I can make a 5, there we go, over 5. Now, since we're dealing with decimals, it's okay to go to your calculator here. And when you do 6.25 divided by 5 in your calculator, you're going to get 1.25. All right. And likewise, when you do 5/4 in your calculator, that's 1.2. All right. And when you do 10/8, that's going to be 1.25. I'm sorry, this should be 5/4 is 1.25. Okay, so we do have that constant ratio of y to x throughout, and that means it's going to be a direct variation. And the equation is going to be y equals 1.25x, or y equals 5/4x. Okay. All right, that's going to be it for this lesson.